All right, so next question. You may notice at first glance that this seems very similar to what we had before. Our given information, we've got mass here, and we've got a coefficient of friction again. Now, I didn't bring it up on the last one, it was the initial concept, but the other question was static friction, and static friction means things are stationary or still or stuck. When I think about that, resting objects. Now, kinetic doesn't technically change the math at all, but the fact that this is kinetic friction means that the number is going to tend to be lower. These are random numbers, so that's a bad example. But typically, kinetic friction is going to be lower, and it also means that the object in particular is moving. For our purposes, the way it'll be moving is by sliding. So not rolling or flying through the air, but sliding across the surface. All right, so ultimately we want to do the same thing. We want to find the force of friction. That's going to come from taking the coefficient, which we have at the end, and multiplying by the normal force. So looking at this, part of that's good news because we have mu. Part of it's bad news because we don't know what normal force is, or at least not a value for it. And unfortunately, as per tradition now, we don't have the weight of the object, but we've got mass. So, through some steps we can get there, but this one's definitely not free. All right, so plugging stuff into this, we identified the mass early on. You always want to look at the units and see what kind of stuff you're dealing with, just as an opening strategy, right? So we've got 196 kilograms for our mass, Earth gravity at 9.8 meters per second squared. So, important to know where we're at and what our gravity is going to be. Hopefully that number never changes, because if it does, then something bad happened to the Earth. All right, so normal force here, multiplying those together, looks like 1920.8. The units will combine, as we've already seen several times, and will give us newtons. That finally has fixed all of our issues, right? So we didn't know the normal force, we only had mu, we had half of the numbers we needed, but now that we've gone and figured out the other one, we can put it all together. So mu, this coefficient, is 0.48. So it doesn't matter if it's static or kinetic. The mu doesn't discriminate, it takes all numbers. The normal force, that one, I guess, technically is a little bit pickier. We have to be careful and make sure we're finding the right type of force and the right units on it. All right, then we want to multiply these together. We see again that roughly half of the normal force turns into friction, and in particular for this one, that's going to make 921.98 newtons.